Today, we'll be talking about problem solving. So first, when you're going to solve problems, you need to think. All right, so there's going to be a lot of concepts, terms that you'll need to know. So concepts, right? Definition of concepts: the mental groupings of familiar objects, events, and people. Prototypes. So when we're talking about psychology, because remember, if you just look up these definitions, like on Google, always put like psychology after the word so you get the psychological definition. So prototypes are a mental image or best example of a category. The closer an object matches our image of a prototype, the more likely we will recognize it as an example of the concept. So an example of this would be like a bird, right? So a bird we know is a flying animal with two legs and feathers. So if you look at the picture here, this meets our prototype of a bird, so we ID it as a bird. So we use prototypes to enhance memory and recall. Since you can keep a prototype of something and then match it to something new, similar things to prototypes in order to identify, categorize, or store things new. So it's just kind of like how our brain works to identify new things. So when we're problem solving, a couple different things we use. So when you're faced with a problem, we have a few options to figure out the solution. One thing is like algorithms. I'm sure you've heard of this like on TV shows, especially depending if you're watching like kind of like detective type shows. So an algorithm is problem solving procedures or formulas that guarantee a correct outcome if correctly applied. So this is like a mathematical formula that you will definitely get the right answer. It just might take time. So think about if you've ever seen like a movie where they're trying to crack a like the code to a safe or something, right? They're using an algorithm, and eventually every single possible answer will come up, and eventually you'll get it. Well, sometimes you don't have time for that, right? So you use something called heuristics. Heuristics is a simple, basic rule that serve as shortcuts to solve complex mental problems or mental tasks. But these do not guarantee a correct solution. You're probably going to get the correct answer, but it's not guaranteed. So sometimes there is no problem solving strategy, right? Sometimes we just use something called insight, right? Insight is just a sudden and often novel realization of the solution to a problem. So this contrasts with strategy-based solutions because sometimes the answer just comes to you, right? Have you ever, been trying to solve something and then it just comes to you? Maybe it's when you're doing something completely different. You're not even trying to think about the problem you're trying to solve, or maybe you were sleeping and it just came to you, or whatever happened. It's like in the cartoons where they get like the little thought bubble, like the little light bulb goes off, right? That's insight. There's no scientific strategy to it. It just kind of happens. So here is an example of an algorithm versus heuristics. So if you look at all those letters there, what word are we trying to make? See if you can figure it out. Now, if we're going to use an algorithm, there are 907,208 combinations that we could possibly make with those letters. But if we use heuristics, we know that all those of those, over 900,000 possible combinations, we know probably no word has a YY to it, right? So you throw out all those possibilities, now that's heuristics, right? Because now that's a shortcut. It's not every single possible one, but you can take some things out to shorten it up. So think about that. Can you think of any other heuristics that you would use? So problem solving, we're going to go through a couple problems and see how well you can solve them. So this one, so if you want to maybe pause the lecture and try to figure it out, and then later on you'll see the answers as we go through the lecture. So for this one, how would you arrange 6 matches to form 4 equilateral triangles? So think about that. You can only use those 6 and 4 equal triangles. How would you do that? And here is the answer. All right, so you can see there's 6, right? 1, 2, 3, 4, 5, 6, and you got the 3 sides of like the pyramid and the one on the bottom. That's 4 equilateral triangles. Okay, so we'll do a couple more. So remember, if you want to try to figure it out, just pause the video and then try to figure it out and then see if you got it right. I know a lot of students. So this one, you have 3 different jugs, A, B, and C. So using these 3 jugs with the capacity, so there's 7 different problems here. So like problem number 1, jug A can hold 21 units, jug B can hold 127 units, jug C can hold 3 units. How would, based off those measurements, how would you get to 100 units, right? So the problem is you want to get to 100 units using these 3 jugs. How would you get there, right? And then there's 7 of these to do. So once again, if you want to try to figure it out, just pause the video and you can try to figure it out. Here is the answer. So for all 7 problems can be solved by the equation shown in B minus A minus 2C, right? So you fill up the biggest one, then you pour it into B. Oh, sorry. Yeah, so you'd pour it into like the 20, so like the 127, you'd pour 1 into the 21, and then you would pour 2 into C, right? So you start off with 127, then you get rid of 21, now you have 106 left. Now you fill up 3 twice, now you only have 100 left. Remember, problem 1, that's what you're trying to get to. So that's literally how you could solve all 7 problems can be solved pretty much that way. But maybe a simpler solution exists for problems 6 and 7. So 6 and 7, you can just do A minus C, right? And so that saves a couple steps. All right, so here's another problem for you. So if you have 2 buckets of water, one which is 20 degrees centigrade and the other which is 20 degrees Fahrenheit, and you drop a ball into each and they fall from the same height and speed and hit the water at the exact same time, which ball hits the bottom first? So think about that for a minute. All right, 2 buckets, one 20 degrees centigrade or Celsius, the other 20 degrees Fahrenheit. Which ball hits the bottom first? So once again, pause it. I'm going to go on to the answer if you want to try to figure it out and you haven't yet. The answer is the one that fell in the 20 degrees Celsius bucket because 20 degrees Fahrenheit is ice. So if you know anything about Celsius and Fahrenheit, the freezing point at Celsius is 32 degrees. So anything below 32 degrees Fahrenheit is freezing, so that's ice. So obviously the ball can't get to the bottom of the bucket. Well, freezing at Celsius is 0 degrees, right? Is 0 degrees. And one way, a lot of people don't know how to figure those two out. So I learned this a long time ago. So if you start there, right? So if you start at 0 degrees Celsius and 30 degrees Fahrenheit, it's the freezing point. Well, every 10 degrees Celsius you go up 18 degrees Fahrenheit. So then 10 degrees Celsius would be 50 degrees Fahrenheit, right? Because 18 plus 32 is 50, and then 20 degrees Celsius would be 68 Fahrenheit, and you just keep going that way. And then you go backwards the same way. There is one where it's the exact same, negative 40, right? Negative 40 is the same Fahrenheit and Celsius. Just a little facts for you guys today. All right, so here's another problem. See if you guys can solve this. This is a candle mounting problem. All right, so using these materials, how would you mount the candle on the bulletin board? Once again, if you want to try to figure this out, just pause the video, maybe try drawing it out, try to figure it out, and see if you can. And I'll show you the answer here. All right, so you take all the matches out. You don't need the matches. Use the box, use the thumbtacks to push in the matchbox, and then you put the candle in the matchbox. All right, so getting back to some of the vocab that you guys need to know. So what we're going to be talking about now is what's some obstacles to problem solving. So what are some of the things that get in the way to us solving the problem? Confirmation bias is one that we've heard before. There's a video that I'll add to the playlist that's a good video that talks about confirmation bias. So confirmation bias is the tendency to search for information that supports our preconceptions and to ignore or distort contradictory evidence. So if you see the cartoon down here, it says everyone seeks confirmation bias. Ah, I knew it. And then he's like, oh, he just did confirmation bias, right? You see confirmation bias all the time. If you follow politics, I mean, that's one of the big problems now is people only want to find evidence of what they believe in, and anything that doesn't, fall into like their category, they don't believe it at all. And so we'll see lots of confirmation bias. And I'm sure if you think about it, you see a lot of confirmation bias in your everyday life. Fixation is just the inability to see a problem from a new perspective, right? Sometimes you just get focused on one way of doing something. It's hard to see from another way. That's why sometimes you need to step back. So sometimes if you're trying to solve something, it's almost better to step away, come back a couple hours later the next day, and then you might be able to solve a problem. And this could be, I mean, just think even like reading, like in English, right? Like you're writing a paper. That's why they always say have someone else proofread it because it's like a different perspective. Sometimes you get fixed in the way you see it and the way you look. So continue on with problems with heuristics. So one problem with heuristics are mental sets. And you see the definition down at the bottom. So when faced with problems, we have a tendency to approach it in a familiar way, especially a way that has been successful in the past, but may or may not be helpful in solving a new problem. So a mental set, the definition, the vocab word you need to know, is the tendency to respond to a new problem in the manner used for previous problems. Right? So if it's worked before, then you try to use that same way of solving all problems, but it doesn't work for all problems. So another problem with relying on heuristics is called functional fixedness. So it's sort of mental set issue. Right? So functional fixedness is the inability to perceive a new use for an object associated with a different purpose. Right? So a wrench is used for like plumbing or whatever. You can't. So functional fixedness is not being able to see that wrench and have multiple purposes for it. So once again, there's a link here, but I'll have to post it to the playlist, is examples of functional fixedness. And so you see this, or people who don't have functional fixedness. So people who can think outside the box, they don't have functional fixedness. So like the example on the screen here, you have a person, she can't reach both ropes. Well, um, the person on the left has functional fixedness. The person on the right does not. They realize they can use that wrench looking thing, whatever that is, and they can extend their arm to make it longer. Now they can use it. So in the video, and there's a bunch of like videos you see on the news all the time about people thinking outside the box. So one is where someone takes like a large TV box and they use it as like a snowplow, right? So that's thinking outside the box. There was an old show called MacGyver, and actually they remade it a few years ago. But I grew up as a kid watching it, and he would always get himself in some kind of problem, and he'd always get out of it with like finding these random things by him that no one else would think of, right? So he did not have functional fixedness, and he always had duct tape, right? Always had duct tape, whatever it was. That was always, he carried that around everywhere with him. In fact, as a kid, I used to call it MacGyver tape because that's what he used all the time. So representative heuristics. So judging the likelihood of things in terms of how well they seem to match a prototype. All right. So going back to that prototype. So stereotypes are common. All right. So these are common representative heuristics that we use. So if you would go back, right, a little ways, so go back over 30 years, and it's 1989, and you were told that one of these two celebrities would end up doing family-friendly movies for Disney, and the other would end up on trial for multiple sexual assaults, who would you choose? All right, so most people would probably choose Bill Cosby as doing the family-friendly ones, right, and not Ice Cube. But because that's representative heuristics, we're stereotyping them. That's, we use shortcuts to figure out answers, and that's what stereotypes really are. But obviously, they're not always correct. Availability heuristics. This is estimating the likelihood of events based on their availability and memory. So if instances come readily to mind, we presume such events are common. Right? And we'll see this on the next slide. So a lot of this has to do with like what you see on TV. So it's whatever you see all the time then that's what you tend to believe. So here's some examples of availability heuristics. So sharks, we always think about how dangerous sharks are. They kill about 5 people a year. But cows kill 22 people a year. Ants kill about 30. Horses kill about 20. Hippos are actually very dangerous. If you ever go to like Africa, they're actually one of the most dangerous things. They'll tip your boat over. They kill, this one has 2,900 people annually. Jellyfish can kill about 40 people a year. And deer actually kill about 130 people a year. I gotta imagine a lot of that has to do with them running in roads and causing car accidents. But we always see that sharks are so dangerous. You got the movie Jaws and all those things. So because it's in our mind, that's what we think is the most dangerous. Overconfidence, right? This is the tendency to overestimate the accuracy of our knowledge and judgments. So someone might say, I know there's 7 trillion people in the world, right? You ever know those people that are overconfident about everything, right? They just know the answer to everything, but then they tend not to be right. I got an argument with my wife one time. We were freshmen in college, and she's like, I know there are 3 trillion people in the world. And I'm like, like that's something I usually follow. Like for whatever reason, I keep track of stuff like that. I like human geography. And I'm like, no, there's 6.18 billion people. And she was so sad until we looked it up. So some of these people, they just tend to have overconfidence. Belief perseverance phenomenon, right? This is clinging to one's initial conceptions after the basis on which they were formed has been discredited. Right? So to control this, tell them to consider the opposite perspective. People become less biased in their evaluations of the evidence. Also watch out for framing, right? That's the way an issue is posed to a group. So if you say, oh my God, you have 95% success rate, that's awesome. So you might think something's good. But if you say, my God, like 5% of you failed, right? It's the exact same thing, but it's just how you frame the question or how you frame whatever you're talking about can get you thinking in a certain way. And so you see, once again, like I'll talk about politics a lot in general, not specifics, but you see this belief perseverance phenomenon a lot in politics, where even though after someone, something has been discredited, and I could give a lot of examples right now if you're watching politics, people still don't believe it, right? And you see that in the election. So along with mental sets, bias can make heuristics a faulty decision-making tool, right? So a couple different other biases, and there is like just tons of different types of bias out there. And like some of these, like hindsight bias, we've already talked about. I do have a chart that has like all these different types. I try to show you guys the most popular ones. So hindsight bias, like we talked about at the beginning of the year, is the tendency to second guess a decision after the event has happened. So like afterwards, kids will be like, oh, I knew the answer was A. Well, if you knew it was A, why didn't you choose A, right? That's hindsight bias. So I do this with sports all the time. Like let's say I'm trying to I'll do like a weekly pick 'em in the NFL with friends. And if I pick something wrong, I'll say, oh, I knew that team was going to win. But if I knew it, then why didn't I choose it, right? That's hindsight bias. Is after the fact, knowing something was going to happen. We also have representative bias. This is judging the likelihood of things in terms of how well they seem to match particular prototypes. And then the last one, I can't show the video on here, I don't think. So I will try to post this on the site as well. And that is the end of problem solving.